This is a very squished version of what our studio's console looks like. Our studio is what's called an IDE. So it's a full development environment. This is different from what you'll be shown later, which is a notebook. There's some pros and cons to having a full development environment. There's people in one camp or another camp. This isn't nearly as shareable and as portable as something like a notebook is, but you can share like that HTML file that I generate. So think about what you want to use the tool for before you go with it, because you can use R code in Jupyter, which you will be shown next, but this is just another way of presenting it. It's got a couple of panels here. You can see I'm messing with it just by dragging. And what I have here and what I see some people who are really new to programming having some trouble with is understanding the console and its relationship to the text file or to the actual code file. So this will hopefully make this a little bit more clear. What I've got here is my R Markdown file. This is all the code that I wrote with Zach to actually do this presentation. So this is all of that is all up here, and it's an R Markdown file on this tab. I can create a new R script or a new R Markdown file just by going up here to this little button, and it just creates a new tab. And all that is just a text file essentially with a different extension and with different types of markup. So we're librarians, we're all probably pretty familiar with what markup means. What I'm doing here is I'm taking all the code I want and I'm just putting it in these little dashes. This is like my tags essentially I'm using in R. It's just tilde with the R in brackets, but you could use another programming language if you wanted in this. It's just not commonly used that way. And so I put all the code I wanted in here, and I installed the package knitter. It's K-N-I-T-T-E-R. That's in here, but other than looking sideways and looking for it. What you can do once you install that package as knitter, or even if you just click this button and you don't have it installed, it'll prompt you to install it, so don't worry about trying to figure out what package it is. All I do is I write my file here, I click this button that says knit HTML, and it runs some code down here in the console. So that's the distinction I'm trying to make, is this is the console. I write and edit my code up here, and I run it in the console. And you can do this iteratively. You can take code out that you don't necessarily, you just want to see what it does, type it directly into the console. Or you can keep your stuff that you're just trying to mess with up in the file. But there's a distinction in RStudio made between the console and the file. And what you see that was generated when I clicked knit to HTML was this HTML file, which you have the ability to then open in a browser. So having some trouble doing multiple windows on here, but typically that would launch it into a browser. Or there's this little button up here that if you set it up and go through it, I don't want to do that, this isn't my computer, but you can log into something called rpubs, which is the link on the GitHub repo. If you don't use GitHub and you just follow the link will lead you to an rpubs page, which is my rpubs page where my publications of R are hosted. So you don't need R or anything to look at all these things on rpubs. So that's how you would publish it to rpubs, and this is how this kind of works. And so that's the actual interface itself. You can see over here, you can tab through here if you're just working on this on your own. Any of the plots you generate, you can scroll through over here and export them in at different dimensions or in different file types. And you can use this little package manager if you like, or you can manage all your packages via the command line. So I encourage you to try that out. And the analyses we're going to be doing, if I can go back to my window where my actual file is. There we go. Like I said, they're focused on giving you a better idea of doing descriptive visual inspection, and we're going to start with just the base functions, but we're going to be using a package called ggplot2. It's Grammar of Graphics. It was written by Hadley Wickham, and ggplot2 is like the package out there for doing visualization. There's a couple of other syntaxes for visualization, particularly lattice, which is another package that we won't focus on. But lots of other languages are implementing the grammar of graphics, this ggplot language that Hadley Wickham kind of came up with. And what it helps us do is we can create an object, and then we can create that object in a way that's sort of very easily human readable with a very easy to follow syntax. And then what we do is we add layers. So always you're starting with a blank canvas, you plot your object, you say what my object is going to look like, and then you plot it on the canvas. And you can add layers. So that helps us create really dynamic, really complicated visuals pretty quickly. So Zach's going to walk you through those examples.
Yeah. Although I will say that the first example we see here is not actually done in ggplot2.
No, it's ugly.
It's actually done just with the base graphics. And part of the reason we wanted to show you this is so you can just see, hey, R will actually do some of this stuff. And R's base graphics capability actually is pretty good, but you can do a lot more with the packages. To reiterate, one of the strengths about R is you've got all these different packages that all these different people create. And of course, there's pros and cons to that. Some people create really good stuff. Hadley Wickham created like half the packages we've shown. He creates good stuff. But there's other people, you could create a package. I'm not saying you'd create a bad package, but you know, there's pros and cons to having lots of different packages for lots of different things. So this very first plot, we've just created a small little dot plot. And what we've done up here is, again, we're using the same data set, the diamonds data set. So the data set that we played with in the wrangling example is the same data set that we're playing with here. Diamonds is a data library within ggplot2. So you don't have to install diamonds. If you install ggplot2, you will have diamonds, and you can play around with diamonds on your machine. And it's a pretty good test set. But what we've done here is we basically said, okay, on the x-axis we're going to label the caret, and on the y-axis we're going to label the cut. And then we've got all these various little dots, and that's our data visualized. How many of you can make sense out of what you see up here? Somewhat. I mean, it's there. I mean, we can see some outliers with the different cuts of diamonds. Okay, so we can see that some of the ideal cuts have different outliers from the fair and good ones, and we can see, you know, there's some bigger diamonds and there's a whole bunch of small diamonds, but it could look better. Part of the process with analysis is trying a few other things to see if there's something that will make it look a little bit better. And so we're going to try another base plot. Okay, like this is not using ggplot2. We hadn't moved into that, but all we're going to do then is have something come out where plot diamonds caret, diamonds price with base price. How expensive are these things? And we come up with this. So, I'm going to actually need this.
Yeah, right.
Yeah, because I like to walk. So a lot of, this isn't cheap, but a lot of cheap diamonds that are small, and then you start getting out here, and you can kind of see that there's a trend, okay? Like this diamond's huge and it costs a lot of money, right? Yeah, but it's kind of far out there, and you can see all these dots, and we can tell there's a lot of them. Yeah, but what is this? We can make sense of this, but there's a better way to make sense of this with perhaps looking at the individual types of cuts of diamonds and their prices. Does that really follow me? So we can make some sense of this, but we're going to actually do something slightly different. And now we're going to actually move into the ggplot functions. So what we're going to do is, how many of you have heard of a box and whiskers plot? Or a stem and leaf plot? Okay, this is a plot. It's very popular in the statistics community, and it's gonna look like a box with some stems or some whiskers. It's basically what it'll look like. And so we've done some of this little coding right here. And now we get this. Isn't that beautiful? Yeah. And so now, so you saw the other two graphs, right? Can you make more sense of those graphs or of this one? How many of you vote for options 1 or 2? How many of you vote for this option? Most of you are abstaining, but the few of you who are voting voted for this one. Okay? And so I'm going to explain a little bit about what these are. Some of these dots right here, they're outliers. So this box right here is 25, 50, 75. And this line down here is 0. And at the very top, we got 100. Okay? That's sort of what each of these things mean. So you can see that we got lots of outliers clumped together here, lots of them clumped here, lots of them clumped here. And then for the fares, we see there's a handful at the very top, but this box is a little differently constructed from this one, and this box is a little constructively from this one. We can make more sense out of how our data looks with the sort of the different quartiles of our data and how they're represented here with this stem and leaf plot. But stem and leaf plots, box and whisker plots also sometimes have a problem. It's nice to know that this is the mean value, but what happens if we have a data set that has a lot on one end and a lot on another? Well, you're not going to be able to tell that from this, okay? This is good. You can sort of get an idea of what's going on. But if there were a whole, like for this one, if all the values were clustered up here and all the values were clustered down here, you'd have no idea, okay? So we're going to actually use ggplot2 to create a slightly different graph. And this one is called a violin plot, okay? Because it'll look like, well, it won't exactly resemble a Stradivarius, but it'll come pretty close, okay? So again, one thing I'm going to point out, diamonds box, ggplot diamonds, caret, box plot, diamonds box, right? Can we remember that? Because the screen's a little bit too small. All we did was just change this code around very slightly. So we got diamonds box, box plot, diamonds violin, same code right here, G and violin. So we've taken the same code, tweaked the words very slightly, and now we're going to get a completely different plot. This is sort of going from a base plot and building our way up. And now we get this. Now, we could understand what was going on a little bit better in the box and whisker plot of the stem and leaf plot, but now we built on another layer. So now we can see, yeah, there's a lot of diamonds in this range for fair, and that probably kind of lines up the same. And ideal, yeah, that kind of lines up, but premium. Here's an example. That line was kind of in the middle, right? You see? Well, we've got two large edges here. We can't really, we've got sort of this stratified thing that we can't really determine, because otherwise you'd see that the middle value was probably somewhere around like here. But that's not where the mode is. That's not where the most number of diamonds were. Most number of diamonds are probably down here at the bottom. But you can't really tell that based on the first graph. So now we've sort of analyzed a little further by just changing some of the code, building up off of each other. And now we have a slightly different graph to tell us a little bit more about what we have. This sort of makes sense? So now we're going to put on another layer, okay? So this is just like going outside when it's cold, okay? We're going to put on another layer. And all we're going to do is we're going to take the same graph, the same plot, and we're just going to add some points, okay, so that we can actually see where each representation is. And we get this. Now, you see all the points here, and they kind of look like something that we might have seen, oh, I don't know, up here. Kind of looks like that. But this doesn't, I mean, we can gather something from this set plot right here. But now, by doing a little bit more analysis, running a few other lines of code, whoop, can't see the next example yet, it's too cool. Now we can actually see, okay, we've got the same lines that we saw in that very first dot plot. But now we actually can see these straight bold lines. You can't tell how many diamonds are in there. It's just one solid black line. Unlike up here where we can see there's a diamond, there's a diamond, there's a diamond. We have no idea the number here. But now we can say, oh yeah, most of our fair diamonds are in this range. Most of our good diamonds are in this range and maybe a little bit here. We've got most of our ideal diamonds that are very small. That's just so unfortunate. Why can't we have this huge ideal diamond? But most of our ideal diamonds are down here. And that's sort of how the analysis process works. But we can also try to make a different graph and see something completely different. So what we're going to do is create a heat map. Okay? Now for this one, we had to install another package. So we've done that, our color brewer.
You don't have to install the color brewer. I just wanted it to be pretty. So you can create your own color palettes and stuff. That's not required.
Yeah, well, you want it to look pretty, right? So anyway, what we're going to do is again, the same sort of things that we've been doing before. We're going to select a couple of the attributes, put it into a graph, and then call it out. And so this is the string, so this is what we've called out, the variables that we've got here. And now, by running this, we can view this. And so now we can see these diamonds are very expensive, but they're also ideal and the best color. Whereas these diamonds are a little, they're not quite as clear, but they're still really good color, so they're still expensive. But over here, these diamonds, they're worse. But you can see a general pattern. So we've got the darker from red down to blue, and so it sort of actually follows that. We can see the red coming sort of down to blue. This is sort of an aberration. I'm curious as to why that is. Maybe there's more of those there, or maybe there's something else going on, or we have a smaller sample size down here. We don't really know that.
Maybe the cut's bad.
Yeah, but we could guess that by doing a little bit more analysis. But this is another example of, this looks beautiful, okay? Some of you are like, come on now, this doesn't look beautiful. It looks far more beautiful than what you can get out of SAS or Stata or SPSS or most of the other languages for statistical computation. Sure, something like Mathematica is going to have far more beautiful graphics than this. But Mathematica is also A, extremely expensive, and B, serves a different function.
And this was really easy.
Yeah, this was...
It's just a couple lines. It looks like it's a bunch, but if you look at it, you're just adding geomes, different gradients. I just add, instead of geome box or geome violin, geome tile. Like a lot of these things, once you get used to looking at the R syntax, you can see how simple this is to build. And there's a lot of examples online to show you if you can't figure it out yourself.
That is one of the, because of our sort of open source community, it is very good for that sort of purpose. But that's sort of the walkthrough of how we can do analysis using some of the visual elements within R. We started with just a couple lines, and then we got it down to this. And now we have a much clearer idea of what our data is visually represented like, all by just changing a few lines of code.
So, questions? We wanted to keep the example simple, but if you go into any of the documentation on ggplot, there's galleries of different kinds of plots you can make. There's something called the R Graphics Cookbook, which I encourage you to go pick up. So these things are kind of like recipes. You need to know enough about analytics to know what you're plotting and to know that you're not cherry picking and you're not like arbitrarily deciding something is an outlier, or that you're not making unrealistic comparisons that just sort of prove your point. You need to know what you want to plot. But then once you have an image in your mind of what you want the graph to look like, there's probably someone else out there who's made a plot like that. And so you can find more examples. And if your data isn't shaped or structured the way that it is in the example, you know how to start splicing it up and making it fit so that you can do something fun. But yeah. The end again.